Before we get started with RIP version 2, I wanted to point out a few differences between the original RIP version 1 and version 2 that we're going to cover in this course. Version 1 was a classful routing protocol. RIP version 2 is a classless routing protocol. Version 1 sent its RIP updates via broadcasts. Version 2 uses multicast for its updates with the multicast address of 224.0.0.9. And then, of course, version 1 did not have any variable length subnet mask support, and version 2 does support VLSM. RIP version 2 is a pretty basic dynamic routing protocol. Once it is configured on our routers, the routers are going to advertise RIP messages via link local multicast address 224.0.0.9. Then the routers will advertise connected routes that are defined with network statements underneath the router RIP process. RIP version 2 is a distance vector protocol that uses router hop counts for its metric. If we take a look at this example, which route is best to get to the 10.300 network from R1? Since we just care about hop count with RIP, we're going to see how many routed hops we have for each path. If we look at the path through R2, we see that we have 2 hops. Our next option is to take the path directly from R1 to R3, which would obviously be 1 hop. Since the lowest hop count wins for the RIP metric, then the path directly to R3 would be considered to be the preferred route. All dynamic routing protocols have an assigned administrative distance value. RIP version 2's administrative distance is 120, which is worse than most routing protocols. If we take a look at this example, and we want to see which route is best to get to the 10.1200 network from R3, we'll see that R3 will be learning the route from both RIP and EIGRP. And the tiebreaker between both route advertisements from the 2 different routing protocols will be the administrative distance, which, of course, RIP has the higher administrative distance compared to EIGRP's AD of 90, so R3 would choose the EIGRP path since its administrative distance is lower than the RIP routing protocol, because the lower administrative distance is considered to be the preferred routed path. RIP version 2 uses split horizon and route poisoning to prevent routing loops. Let's take a look at an example of how split horizon works. Let's say that R3 advertised its connected 10.300 network to R1. With RIP, R1 would take that route advertisement and advertise it over to R2, but it would not advertise it back to R3 because of split horizon. Split horizon rule says to not advertise a route out of the same interface that learned about the route. So since we learned about the 10.300 route on the interface that's connected to R3, we would not advertise that route back out to R3. Route poisoning is another method for RIP version 2 to prevent routing loops. In this example, let's say that R3's connected 10.300 interface had failed. To prevent routing loops in the routing topology, R3 would introduce route poisoning by advertising that same network with a metric of 16. And this is how route poisoning works, by advertising any failed route with an infinite metric of 16 to flush out the existing routing table entries for that route. So when R1 and R2 received this route advertisement, they would discard the 10.300 route since it had an infinite metric. The reason that a metric of 16 is considered to be infinite in RIP is because with RIP, it can only have a maximum hop count of 15 for its metric. So a RIP routing topology cannot exceed 15 routed hops. One key feature to understand with RIP version 2 is auto-summarization. In certain scenarios, RIP will actually automatically advertise classful summary routes for classful networks. And in this example here, since R1 and R2 have this 172.16 class B classful network in between them, since this could be considered a discontiguous classful routing topology, if R1 or R2 wanted to advertise their connected 10-dot networks and auto-summarization was enabled, R1 would actually advertise a classful summary route for the 10 network to R2, and R2 would also advertise a 10-dot summary advertisement to R1 to represent the 10.2. Because when auto-summarization is enabled, the routers think, well, you know what? I don't have a 10-dot network on this routed connection to R1, so I'm just going to say, hey, if you need to get to 10 anything, come to me. Sometimes auto-summarization is okay, but imagine if we had another router in the mix and R3 wanted to get to the 10.1 network that's connected to R1 and the 10.2 network that's connected off of R2. Well, in this scenario, when R3 wanted to get to either of those networks, it actually would have two summaries, one to R1 and one to R2, that by default would be equal cost. So when it wanted to send traffic to 10.1 or 10.2, it would actually be equal cost load balancing its traffic, one packet to R1, one packet to R2, depending on which network it was going to. And you can see how this could really cause some issues in a network because R3 doesn't know the right path to go to get to the specific networks. To fix this problem, we can disable auto-summarization with the no auto summary command in our router RIP configuration. And that's really best practice. I mean, most of the time it's better to rely on manual summarization, so any routing protocol that has auto summarization, just disable it. Some software versions now have it disabled by default, but just remember that anytime you're configuring RIP, just put no auto summary under your configuration. And then once you enter the no auto summary in a topology like this, then R3 would learn the specific routes, so it would know exactly where to go for the 10.1 and 10.2 networks. Now, if the topology would have looked like this, and we had the 10 network between R1, R2, and R3, then we wouldn't have had this problem even if auto summarization was enabled, and R3 would have learned the specific routes directly to R1 and R2. Now we're going to take a look at how RIP version 2 advertises a default route into the RIP topology. Every dynamic routing protocol has a different method for advertising default routes. For RIP, to advertise a default route, you simply add the default information originate command underneath your router RIP configuration.